Okay, very good evening to everybody. I hope everyone has. Okay, is it audible now?
Yes, yes, ma'am. But there is echo.
Now, no, right?
Yes, yes, ma'am. Yes.
Yeah,
Okay. So I'll turn my volume on from here. Okay. Very good evening to everybody. My name is AnanyaNath. I'm a PhD student at IIT Delhi, and welcome to the first week one doubt clearing session on fundamentals of additive manufacturing. So, is my voice is clear now, and or
Yes,
any noise?
yes, ma'am. It's clear.
Okay. Okay. So maybe we can start our lecture or doubt clearing session now. But before that, it will be great if all of you can turn on your video, at least for the first class, so that we can have a introduction session. I can know about your backgrounds and what you are doing and why you have taken this course. Because week one lecture is not that tough, we can cover easily and clear your doubts. But before that, is it possible for all of you to turn on your camera? Okay. So, a brief introduction about myself first. So, I have already said I'm a PhD student at IIT Delhi. Right now, I'm in my fifth semester. Actually, I have started my fifth semester, so third year, and I have a PMRF. So, for that, I am doing my TA duty here. And my PhD topic is also metal based additive manufacturing. I guess that's why they have selected me as a TA. And yeah, that's all about me right now. So you all can also turn on your audio one by one and tell me your background or what you're doing right now and why you have taken this course. Whether you have any background on additive or not, or this is a completely new session for you, or what are the things. Okay. So Deepak, your mic is on, so you can start. Yes. Anyone?
Hello, can
Yes.
you hear? Yes, yes.
Yeah, yeah. We
Myself,
can hear you.
Dr. N. Tangapandian. I'm an associate professor in St. Joseph Institute, Chennai. Actually, now I'm doing AICT PG diploma course in additive manufacturing. As a part of that, I have to get 2 3 credit subject. That means I have to get 6 credits within this semester. So I'm taking this one and another one by IIT Kanpur professor in additive.
Okay. Okay.
Thank you.
Great. Anyone else? All of you can actually tell me your introduction. Your mic is off, Deepak.
Madam, I am Deepak Kumar Sethi, and I have registered for PhD at IIT Dhanbad. So I need to
Okay.
do some coursework, at least 9 credits. So I have selected this
Okay.
subject.
Okay. So, are you going to work on additive, or this is just a course to complete your credit?
No, no, I work, but we are on the process of purchasing one machine. That after
Machine
that,
on?
additive manufacturing, that is actually polymer based. That
Okay.
is under
Great.
the process. After it comes to our lab, we'll start working.
Okay. You are from IIT. What?
IIT Dhanbad. No, I have registered for
Oh,
PhD, but it is a part-time
okay.
course, so I am doing through
Okay.
online.
Okay. Okay. Nice. Next.
Hi. Good evening, madam.
Good evening.
Yes, myself Naidu. I am registered for PhD at NIT Bhopal, MNIT Bhopal. As a part of coursework, I
Okay.
am doing this additive manufacturing as a partner. I'm belongs to metallurgy.
Okay.
Metallurgy.
Next.
Thank you, madam.
Good evening, everyone. Myself, Dr. Santosh Bhagyawadi. I'm basically from Karnataka. I've completed my PhD in additive manufacturing, especially in working with oxidic materials from Vellore Institute of Technology, Vellore campus. So, currently, I'm working as an assistant professor at Dr. D.Y. Patil Institute of Technology, Pimpri, Pune. It is located in Pune. And, I've taken this course just to have a certificate of this NPTEL. Was the requirement in our institute, so I've taken this course. Sorry, I am not able to turn on my
Okay.
camera.
Not an issue.
Yeah, thank you.
Okay. Next. Then you might know better about additive manufacturing than me. So if I make any mistake in between my lectures, you can correct me anyway.
Yeah, sure. Although I worked on purely on polymer additive manufacturing, this FDM, okay,
Okay.
I have very little or basic level of understanding on metal additive. So
No issue. This course is on fundamentals of additive. So
since you
okay,
since you
next.
mentioned about metal additive at the initial, so
Yeah, yeah.
I thought,
I am working
yeah,
on metal additive.
yeah, right.
Okay. Next. No one? Okay, how many of you already have a sense of additive manufacturing previously in your previous work or previous degree? Okay, you can raise your hand actually. Very less number of people, I think. Okay, nice. Then you all get to know about a very interesting topic throughout this 12 weeks of lecture in NPTEL, and you can clear your doubts here throughout this 12 weeks from me. And there are other TAs also taking this course for doubt clearing session. So I'll hope this will be a great learning session for all of you. So we can start today's doubt clearing session now, I think, because no one of you is interested in letting me know your introduction anymore, I think. Okay.
Good
So
evening, ma'am.
additive manufacturing. Yes, somebody called.
Ma'am, this is Anbarshu from Sri Sairam Engineering
Right.
College, working as an assistant professor in the Department of Mechanical and Automation Engineering. While I'm choosing this course because of doing an domain certification for product design. So that's why I chosen as an elective course for this subject. Thank you.
Okay, I'm starting this lecture or doubt clearing session. If any one of you have any specific doubt on week 1 lectures, lecture 1 and lecture 2, you can raise your doubt afterward. Before that, I'll give you a brief introduction to additive manufacturing, as many of you are new to this field, I believe, upon your raised your hand things. So, additive manufacturing is a layer by layer manufacturing process where somehow we deposit material in a layer by layer fashion and the whole part is made. Yes, Anuj, you have a doubt. You can ask me later. I'll give a broad time for the doubt clearing. First of all, I'll give you an introduction from my side about additive. Then I'll take your doubts and we'll try to clear the doubts. So, as I was telling you, in additive manufacturing, the material is deposited on a particular platform in a layer by layer fashion. So if I compare this additive manufacturing, like which is also known as 3D printing, with a normal inkjet printer, like the printers we all have in the shops nearby, in the stationery shops, or some of you may have printers in your home also, where we print PDFs or uh, Word documents to print on a paper. So, in terms of that printing, how it is difficult, the 3D printing, how it is difficult, how it is different. So, you have a doubt, I think. So, in 2D printing or in inkjet printing, we supply the machine the PDF or the Word document, right? And after pressing the print button, the PDF or the Word document that we have supplied to the machine or to the printer, it prints over a A4 page or A4 paper. And how it prints, it just deposit a droplet of ink. If this is a printer, someone is presenting something or by
Yes.
mistake.
Yeah, can you?
Yes. Is it by mistake or you want to tell me something? Left. Okay. So if this is the printer, okay, it's gone. This is the printer or inkjet printer. We have a paper. This is our paper. So over the paper, the ink will get deposited drop by drop, and the alphabets will get printed. The alphabets which were present in the PDF or Word document that we have supplied to the machine. So here also it's a layer of ink that is getting deposited over a paper, and the word A or word B is getting printed by drop ink. This is also a layer, but this is one layer of ink. So this is not a layered manufacturing. If now suppose you are doing this process for 400 layers, you are depositing the same ink on the same paper 400 times on the same place or same position. What will happen? The alphabet A will have now a thickness like this. Anyway, the paper cannot sustain that 400 layers of ink. It will get torn or something. But if the paper is very thick and it can sustain the thing, then we will have a with this much thickness now, because this much thickness is coming from 400 layer of ink. This is what additive manufacturing means. So in additive manufacturing, there are several techniques. According to ASTM standard, we have 7 different technology in additive manufacturing. And from that, there is one technique or one method where we really use ink as a raw material. Okay. So here in, if I draw a comparison between 2D printing and 3D printing, then first is the raw material. In 2D printing, we use ink as a raw material, where in 3D printing, we can use ink, we can use metal, we can use polymer, and even we can use different forms of these metals or polymers. Like for example, ink is a liquid, metal can be solid metal, but again solid metal can be powder or in wire form. Then again polymer can be in liquid form or wire form. Again polymer is having two different segments or two different types. One is thermoplastic, one is thermosetting. Now for both this type of polymers, we have different technology in additive. So additive manufacturing is this much vast, and we can print literally any type of material these days. Even people are building houses in China, Japan using 3D printing technology, where they are using raw material as cement, sand, bricks, those mixtures. So now we can think of it like before, the advantage of 3D printing was getting any type of shape and structure out of a particular raw material, either in wire or powder form. Like any type of intrinsic geometry or very complex feature like lattice structures, we can get or we can manufacture using additive manufacturing, which in other way is not possible to make via casting, welding, forming, those conventional manufacturing processes. There, the only problem related to additive manufacturing was the material aspect. So every type of material cannot be used in additive manufacturing. There are very many types of metals, there are many types of polymers, there are many types of inks, and everything was not compatible with this 3D printing technology. But not anymore. These days people are using literally every type of metal that you can use in your industries like aerospace or automobile, or like normal household things, or in research, every type of polymers. Even there previously there were machines, a particular machine capable of printing thermosetting, and a particular machine capable of printing thermoplastic polymer. Now one single machine can print thermosetting and thermoplastic polymer together. Even multiple polymers can be printed together in a particular machine, or multiple metals can be printed together in a particular machine. So now you can think of this topic or this manufacturing technique which is capable of printing any geometry with any material. The second problem related to additive manufacturing was the size, because previously the machines which were there in market was capable of printing few millimeter part or centimeter part. But now there are machines which are capable of printing meters of parts. NASA has recently published an article, and in LinkedIn also you can find the video where they are making huge um, aircraft part using metal additive manufacturing technique. So literally there are no such problems related to additive manufacturing, but in real sense it's not. There are still many problems persisted in additive manufacturing, but those are some other topics. We'll discuss it in the in few last few lectures in this 12 weeks. But for the starting, additive manufacturing is a layer by layer material deposition process. The way birds make their own nest, make their own house, that is how a 3D printer make a particular object, by depositing the material in layer by layer. There will be a raw material, there will be a machine, and there will be some extra parts like what will be the build platform. So in inkjet printer or in 2D printer, we start the printing using a paper, a A4 paper. So we supply a A4 paper to the printer, and we supply the PDF, and then the things which are written on the PDF is getting printed on the paper. So there is one thing which is raw material. So we pour the ink inside the material inside the printer. Second is we supply the Word document or the PDF as something which should be get printed. The third thing is a paper which is acting as a base over which the desired thing will be printed. And fourth is the machine. In 3D printer, first is the raw material. I have already discussed ink, metal, polymer, anything can be used as a raw material. So you have to choose the 7 different types of additive manufacturing process according to ASTM standard. Because if you are asked a question like, I have a polymer, I have a PLA, for example, polylactic acid as a polymer, I have a wire of polymer PLA, and I want to print this PLA, and you will say, yeah, use the 3D printer. Now, if you are getting learned with this course of 3D printer, you should know which type of machine or which technique is really useful to print that PLA part. So this is the second thing. Third thing is the base. There, the paper was the base, the paper on which the letters were get printed. Here again, we need a base. So that base is very important. A base on which our deposited material can really get stuck, or can really get diluted or connected to each other, so that we can peacefully print the material over that build plate. So that base is called build plate. It is also called base plate. It is also called substrate. Okay, and fourth is the raw material, how you are supplying to the machine. So, sorry, the fourth is the PDF and Word document that we supply to the printer. In 3D printing, a 3D part, for example, this mouse is a 3D part or 3D object. I want to print this mouse in 3D printer. So I cannot supply a PDF or Word document to the 3D printer. I have to supply something 3D, something like some document which will contain the 3D knowledge of this mouse. So that something can be even a PDF or a 3D model of this mouse. So there are several softwares which are called CAD softwares, computer aided design, CAD, CAD. So CAD softwares are useful to make 3D model of any part or any object or any 3D substance. Okay, so this is the basic difference between 2D printing and 3D printing. And with the reference of 2D printing, I think now it is clear what 3D printing is and how it works. Again, how it works is not that easy. It's very complicated. The process physics of additive manufacturing is really very complicated and very tough. It's not that easy. We'll go into the topic little step by step, but for now, we have to understand how we can supply the 3D model data to the printer so that the printer can print it. That is the first option. If we are having a printer, we cannot print it easily because we have to supply that PDF or Word document to this printer. So how that PDF is getting generated for a 3D model? For a Word document, for a letter, we know how to write it on Word and how to make it in a PDF form. But how to supply some 3D data to the printer? That we'll be knowing today. First is the 7 different classification of additive manufacturing. So I will ask all of you to tell me the 7 ASTM classification of additive manufacturing. So someone or many of you can just turn on your audio and tell me one by one the classification of additive manufacturing. Yes,
SLA.
Rapid
SLA.
manufacturing.
Yes, good afternoon.
Digital
Someone has
manufacturing.
written VAT photopolymerization. Anything else? You can write it down also in the chat box if you're shy to turn on your audio. Second?
Interjetting.
Digital manufacturing. Rapid manufacturing.
Okay. There are a lot of answers. Yes, every one of you is right. But you have to understand one thing, that is under VAT photopolymerization, as VAT photopolymerization is the first classification in additive manufacturing. Here we also called it SLA, stereolithography. But SLA is not the term given by ASTM, so this is not the standard term. The standard term is VAT photopolymerization. So it's better to use VAT photopolymerization because under this process, there are several techniques like SLA, DLP, LCD based printing, then there is UV light based printing, laser based printing, and many more. Okay, so it's better to use the word wet photopolymerization. The next is material jetting. Second is binder jetting. Fourth is material extrusion. Fifth, someone, no one has told me the yes, sheet lamination. Sixth, powder bed. And seventh, DED. DED is my personal favorite because I'm working on DED. Uh, anyway, so these are the 7 techniques or 7 classification of additive manufacturing according to ASTM standard. Again, the way I have written down the names or the processes in 1, 2, 3, 4, 1 to 7 is in such a way that uh, SLA or VAT photopolymerization uses the minimum energy as a heat source, and DD uses the maximum energy in a heat source. In inkjet, the ink is already in liquid form. So the ink is getting supplied to the paper by piezoelectric material, like in drop on demand process or in a continuous process. That is the process used in inkjet technique. Like continuously the ink is coming, otherwise drop on demand. Wherever the ink is necessary, there it will get uh, deposited or it will come from the nozzle. There, no such huge energy or light is needed, heat source is needed, not needed. But here in additive manufacturing, we are depositing a metal or a polymer. Metals are having, for example, aluminum is having melting temperature as 660 degrees centigrade. Our ambient temperature is 25 degrees centigrade. So how we can deposit aluminum in a 3D printing process? So we have to supply or provide some external heat source to the aluminum material, either in powder form or in wire form, which is present in a raw material chamber, so that the aluminum can get melted and deposited over the substrate or the build plate. Now that heat, so how we can provide the heat? We can either use a electric arc, which is common, we all know about a electric arc. Then next is plasma. Plasma is also very useful in other manufacturing processes, also in like welding or so. So plasma can also be used as a high heat energy source. Lastly, there is, or not lastly, third is electron beam. So just an array of electrons coming in a particular path which is having a very lesser diameter, so that all the electrons can get densified in a particular point and we can get very high energy from that electron beam. Fourth is laser beam. Laser is also a light source but more focused, monochromatic, and etc etc. It's having other properties, but it's also very high energy source. So like in LPBF or in a PBF and DED, which are metal additive manufacturing process, they use this type of electric arc, electron beam, plasma, laser as a heat source, so that they can melt the wire or powder metal and deposit over the build plate. So heat source is also important, and heat source is something which is necessarily required for additive manufacturing or 3D printing. So depending upon that heat source, this 7 classification is made from 1 to 7. Like if for wet photopolymerization, the heat source is minimum, and for DED, the heat source is the highest. So these are the basics or basic of additive manufacturing. Now I'll not go into the deep of the lectures, but rather will be interested to take your doubts. So because many of you have already raised your hand, so you can turn on your mic and ask your doubt. I'll try to solve.
Hello. Hello, yes, madam. Good evening, madam.
Good evening.
Yes, the base plate means which type of
Okay.
material will take as a base plate or a
Base
substrate or
plate. Okay.
base metal? Yes,
So
ma'am.
which type of 3D printing process you are talking about?
Maybe if you take DED or maybe in the case of if you are at a high temperature, if you are working at high temperature.
Okay. So again, to go to DED or LPBF, as these are metal additive manufacturing processes,
Okay.
there we print metal powders or metal wires, right?
Okay.
So before that, I have a doubt. This G Meet is showing me that this call will end soon. So I don't know what to do right now. Maybe I'll make another meeting link and I'll share in the chat box. If somehow this meeting ends, you can join that link. I don't know. This is a new feature in the Gmeet. So in the chat box, I'm dropping the link. So everyone, please copy this link because it's showing me an alarm that this call will end soon. I don't know what to do. Okay, so about the query in DD, if you are working with a particular material, for example, stainless steel.
Okay.
So the powder is coming and the laser is coming and it's getting deposited over the build plate. So it is interacting with each other. So when the laser is melting the stainless steel powder, obviously there will be some heat conduction and all those things. Now the second point is, if you want to deposit the stainless steel over a particular build plate, you have to be or you have to ensure about this one topic, that the build plate should have enough capability to conduct the heat which is coming from the laser material deposition. So it's better to use same similar build plate like the metal powder. For stainless steel powder, we use the stainless steel build plate. For example,
Okay.
if you are using any very costly material, and if you cannot find the same material build plate in market, you will go for a build plate material which is having similar heat conductivity like the material you are using. Okay,
Okay.
so it's basically you have to see the heat conductivity of the materials. Not only the heat
Okay.
conductivity, there are other aspects also, but the main and the most important aspect is the heat conductivity. So any other
The
doubts
main
someone is
criteria.
having? Sorry,
One is the main. Hello.
I couldn't listen.
Hello. Hello.
Yes.
One is the main criteria is here it is conductivity. Another one is the metal, the whatever the base plate or substrate should be withstand. Means whatever
Yeah.
that is another criteria also, right?
Yeah. Obviously, for
Mm,
to
yes.
withstand the heat, we take higher thickness of the build plate. so that it can
Yes,
get
that is.
bent when the laser is coming and interacting.
Yes, yes. Okay.
Madam, I have one doubt.
Yes.
Like ceramic powders, can it be used for 3D this 3D printing process, like silicon dioxide or silicon carbide?
You only want to print silicon dioxide or silicon carbide or
Yes,
ceramic
yes,
powders,
yes,
right?
yes, yes.
Okay, so yes, you can do. There is ceramic printing going on in market. There are ceramic printers also. In case of ceramic, again the melting point of ceramics are really very high. It's around 3000, 4000, or 2000 degrees centigrade. So it's not possible every time to melt the ceramic powders. So people use the technology called selective laser sintering, where they just provide the heat source in such a way that the ceramic powders will get heat up but not get melted together, and they can fuse together because of that heat. So that classification comes under the powder bed fusion. So in powder bed fusion there is one methodology called selective laser sintering, one is selective laser melting. In ceramic printing you can use the selective laser sintering one.
And we need some kind of binder this thing also, binder powder, or it is, I mean, self it will
Okay,
do.
in like in binder jetting technique you need a binder, but in selective laser sintering you really don't need any binder, but you can use binder if your powder is something like it cannot get fused together because of its very low wettability or very low heat conductivity, something like that. So you may require some binder there. Otherwise, in SLS or selective laser sintering, we sometimes provide an external force over each layer so that the powders present over the layer can get fused.
Okay, okay, thank you. Thank you.
I don't know why this alarm is coming every time that my plan will get expired, or and my call may end soon. Is my Gmeet not free anymore? Because right now I'm not in India. Is it because of that
No,
or
not like
something
that. If
else?
you
I
have
don't know.
institutional ID, it will be free for, I think.
Okay, okay. Then I should provide another Gmeet link to the NPTEL after logging in through institutional ID. From where you are connecting the Gmeet from my personal email ID, and the Wi-Fi is it's a Wi-Fi, not a mobile hotspot. Okay, any other doubt? Nothing. So have you all seen the week one's lectures and attended the quiz? How many of you have seen the lectures? Please raise your hand. yes. Hands very less. How can you have doubts then if you haven't seen the lectures? So I would prefer, or I would suggest that you please watch the videos first. Then this doubt clearing session will be helpful to you, because I cannot teach all the topics that have covered or have been covered in the lectures, because it's only 2 hours of time. So if you have watched the videos, then I can just brief out the topics covered in week one lectures, and that will be more helpful to you. And if you have attended the quiz, I can discuss the quiz answers also. I'm not supposed to tell you the answers, but I can discuss the quiz. If you have attended the quiz and if you have any doubt from the quiz question, you can ask that also. Actually, I'm trying to log in through my institutional ID because I don't want this call to end very soon. Okay, so we can go with one by one the ASTM standard classifications of additive manufacturing. Someone please tell me what is VAT photopolymerization. It will be great if this interactive session can be I mean this session can be interactive with all of you. Okay, so I'm audible, I think. Someone raised his hand during the VAT photopolymerization. So is he present here? Don't know. Okay. So VAT photopolymerization is over. The next is material jetting. So material jetting means there will be a substrate. The material here is in
Yeah.
liquid
One minute.
form.
Yeah. Can I ask one question?
Yeah, yeah.
Yeah. In VAT, we can use all polymers, or is there any types specifically?
No. So in VAT photopolymerization, in VAT means the container where we store the resin. The resin is a thermoset polymer. So in VAT photopolymerization, we use thermoset polymer.
In in FDM also, we will use this
Okay, in
thermoset only, right?
FDM, we use generally PLA, like thermoplastic polymer. But these days, there are new FDM technologies which are coming in market, are capable of printing thermoset as well.
Okay.
Is
Okay.
it
Thank you.
okay? Okay. So in material jetting, we provide the polymer liquid again. Here also we use thermoplastic. So the material will come in drop by drop format through a nozzle, and this will deposit over the substrate, and the part will be printed. Here the substrate are generally metallic substrate because the adhesion between the printed part and the substrate is very important. And in metallic substrate we basically do something by which the metallic surface can be rough, so roughness ensures the better adhesion of the deposited layer with the substrate. Again, in VAT photopolymerization also we use metallic base. So there is a particular reason why mostly we use metallic base in every technique. In metal additive manufacturings, the metal base plate has to sustain a lot of heat, because of which, being metal, it's very fine and very correct decision in substrate. But again, the thickness of the substrate is also high in case of metal additive. But in case of polymer additive, we take metal as a substrate material, but there the thickness is not that much because it has not option to get much more heat in polymer, because there is no such high heat in polymer additive. But again, it has to sustain a level of heat, at least some heat. So that's why it is metallic always. And also it's very important for the substrate to be rigid at the time of deposition, because the substrate will go up step by step, layer by layer in case of VAT photopolymerization, or it will go down step by step with layers. And there is lead screw and motors attached to the build plate, which is responsible for this step movement. So at the time of step movement, you have to ensure that there is no vibration coming in the build plate. Otherwise, the accuracy of the printing may get disrupted. So that's why also metal base plates are a very good option for 3D printing techniques. So material jetting is this simple. The third one is binder jetting. Again, it's like the powder material is spread over the build plate, all over build plate, and from the nozzle here the binder comes. Binder means some kind of adhesive which will be helpful to adhere the polymer powders together, and they can fuse together, they can get fused together, and they can make the whole part or geometry. So here the binder comes, and also the build plate is heated up so that that binder works better. Fourth is material extrusion. Material extrusion is not the term we use every time to describe this process, but believe me or not, material extrusion is the most available things we people are using in terms of 3D printing. And you can find a lot of material extrusion printer in your college or in your lab or somewhere in research areas. So can anybody tell me an example of material extrusion?
FDM.
Yes. So FDM is the material extrusion process. Even in Amazon.com, you can find 15,000 or 25,000 machine of FDM. So FDM is this cheaper sometimes, but there are lakhs of FDMs also, like FDM which cost in lakh, maybe 50 lakhs, up to 50 lakhs also. So FDM also has a lot of variety in it, but FDM is the mostly used 3D printing technology everyone in research laboratories and in colleges. But FDM is again a commercial name like SLA. Like for SLA, VAT photopolymerization is the ASTM term. Here material extrusion is the ASTM term and FDM is a commercial name. So we will be using this material extrusion term in place of FDM. So under material extrusion, the FDM comes. Okay. Fifth is the sheet lamination process. Okay, I didn't explain what is material extrusion. So there will be a build plate which will get heated up to some extent, and then there will be nozzle where the wire form of material will come. The material will be rounded or be present in a spool kind of manner, and it will come to the nozzle. There are heaters attached to the nozzle, so there the material will get heated up, not really melted, but heated up, and it will get deposited, for example, like toothpaste, in a semi-solid manner. Okay, and it will build the whole component. So there is a very common thing in FDM printed materials or FDM printed parts. You can really distinguish the parts layers present in a particular part which is printed using FDM. So you can see the layers. Wherever you can see a layers, like distinguishable layers in a part, that means it has got printed using FDM technique, because that is the most common one in polymer additive. The sixth or the fifth the fifth is sheet lamination. Sheet lamination is, again, there will be spool, but spool of metal or polymer or paper like sheets. So the sheets will come. Okay, and there will be a laser cutter. So very high energy laser, which will cut the sheet in a manner in such a way the each layer will be a replicate of the product. So if a product looks like this, if this is the sheet, the laser will cut this portion from the sheet, and then the next again is as it is cut, so the rest of the sheet will go outside the machine, and again the next sheet come. The next sheet portion will come. Again the laser will cut the similar portion in a similar way, and then there will be a roller. This will roll and give pressure in all over the part, so that these two metal sheets, cut metal sheets, can get fused together. And this is how every time with every layer the material, the sheet metal will come, or the sheet material will come. The laser will cut it in, or dependent upon the object geometry, and the roller will press it, and the layers get fused together. The sixth one is PBF. According to me, this is the most interesting technique in all additive manufacturing methods. People may have different suggestions as well, as I'm working in metal additive. So here there will be a substrate, there will be a recoater, the recoater, and here the powder will be stored. This stored powder is also called supplier or dispenser. Handwriting is very bad. This recoater will spread one layer of powder over the build plate. The laser will come from the top, and it will consolidate, or it will scan the path where the object needs to be deposited. Wherever the laser is scanning, the powders present over that path will get melted and fused together. If the powders If the powder is getting melted, then it is called SLM. Again, SLM, SLS, these terms are commercial names, so it's better if you call it powder bed fusion. Again, someone has presented his screen and my screen is not visible anymore. So here one process is SLM, selective laser melting, and one process is selective laser sintering. You can write down the full forms. Selective laser sintering, the powders will not get melted, but they will get heated up until the recrystallization temperature, or heated up to a particular temperature, and then they will get fused together. I'll block this person from my call so that he cannot join this meeting again. Okay. So this is powder bed fusion.
Lens comes under also
Yes.
this lens, LENS, laser engineering net shape.
Yeah, laser engineering net shaping is a term uh, which was popular previous time, but this time these are called PBF or laser powder bed fusion process. So again, lens is a commercial name. Some machine you'll find in companies where they call it lens. By 3D system or so, I don't remember. There is one commercial company who sell the laser powder bed fusion as lens, but lens is again same technique like laser powder bed fusion. There is one company called SLM who sells their powder bed fusion machine as SLM. There is one company called EOS. They sell it in the name of laser powder bed fusion. So the ASTM name is laser powder bed fusion, but lens, SLM, SLS, these are some commercial names. I think I'm clear.
Yes.
Okay. The next is DED, and the last one. In DED, again, there will be a thick metal base because DED is a process which is solely used for metals. Because powder bed fusion is used for metals and as well as polymers, but DED is only used for metals as by my knowledge is concerned. And in DED, the highest energy source is used among all 7 types of additive manufacturing techniques. Yes, right. DED is directed energy deposition. How it works, anyone? No one? Any idea?
What's the question? What's the question actually?
How DED works?
Yeah, the laser or electron beams comes and from another source, the wire or powder will come in another way. which will directly melt the powder on wire and then get deposited in the APV.
Yes. So in DD, electron beam, laser, not electron beam, I mean electron beam are and electric arc is mostly used. And the material will come in powder or wire form. So the material will come like this. This is the material, for example, or the raw material. And the laser is coming like this. Like there is a nozzle in which there is a central slot from which, or from the central slot, the laser is coming. There are different configurations, so you do not have to be very worried about this. But for example, here the laser is coming, and from the circumferential small slots, the powder particles are coming, and they all are meeting at a particular spot over the build plate. And there is interaction, there is heat conduction, there is melting of the material. And this is how, if the nozzle moves in this direction, the material will get melted over this build plate like this. And with layer by layer, the whole object will be made. These are the 7 different techniques of additive manufacturing process and how they work. But it's not that simple how I have just demonstrated the 7 different techniques. The process physics of each technique is very complex, very different from each other, and they account a lot of problems and aspects related to the material and the heat source. So if you want to know any topic particular, you can go through the Google or Wikipedia or YouTube videos, or it will be better if you can uh, read some literature or research papers instead, because additive manufacturing doesn't have that good textbooks in market. But again, sir has suggested some books for additive manufacturing. Those are really good books, and you can suggest those books as well for additive manufacturing. So anyway, these are the 7 different techniques. If you have any doubt about these 7 techniques, you can ask me now. Otherwise, I'll go to the next topic.
Then the
In
key
DD also,
difference.
we will have the substrate as the same material, as the same melting material.
Can you repeat the question?
Yeah, the substrate and the melting material is same in DED as well as LBBF.
Yes. You have to choose the substrate in such a way that there is good conductivity or heat conductivity between the substrate and the metal powders, so that they can get adhered together in a better way. Any other questions?
Madam, this powder bed fusion and directed energy deposition, they are quite similar, or that nozzle construction is different.
They both are completely different. There is no similarity between LPBF and DED, other than they both use metals, powders as raw material, and laser as energy source. But again, as for LPBF, I have discussed, like in LPBF, there are lens, SLM, SLS. So in DD also, there is powder DD, wire DD, and WAM. WAM is WAAM, wire arc additive manufacturing. So yes, a wire will come, a arc will come, they both will interact. The wire will get melted and deposited over the substrate. So in LPBF, the powder is already stored here. So for
Okay.
example, the powder level is here, okay, and the recoater is here.
Okay.
This recoater will spread this amount this amount of powder over this build plate by moving like this. Okay, so it will spread the powder over the build plate. Only the laser will come from top, and the laser will move like this and scan the path or melt the powders present over the path. But here in DAD, the whole nozzle is moving. This nozzle is containing two things. There are tubes, which tubes are connected to a very separate um, machine or something where the powder is stored, which is also called powder hopper. And this nozzle is connected to a laser source. Now both the things are coming together in the nozzle, and from the nozzle the powder is also coming, the laser is also coming. That is why directed energy deposition is directly the powder is coming with the laser or the heat source, and they both are interacting simultaneously. And the nozzle will move over the build plate in x and y direction or in z direction, and that layers will get deposited. But in laser powder bed fusion, there is no movement of nozzle because there is no nozzle. There is only on lens and
Only
galvo
laser
scanner
source.
arrangement. Okay.
Okay, madam. Thank you.
Okay.
Yeah, sir. Yesterday, sir gave one lecture regarding the plasma arc material manufacturing, I think.
Plasma arc again. The plasma will come, and it will just melt the powder particles. It's only like the process is either PBF, powder bed fusion, where the decoder will spread the powder. Otherwise, it will be DD, where from a nozzle the powders will come. The difference is the heat source in every process. Like in powder bed fusion, you can use electron beam, you can use laser, but arc is not used. Again, in DD, laser is used, arc is used, and in DD, wire and powder, both type of material can be used. But in LPBF, as the powder is getting spread, so you can think, you can apply your common knowledge that wire cannot be used as a raw material in PBF process. Any more doubts? I think I can shut the door. No doubts? Again, sorry from my side because of this interruption in the class. I don't know what happened in the Google Meet, why it is ending in 1 hour. Even this call is giving me alarm that after 32 minutes, the call will get cut. But anyway, after 32 minutes, this class will also get finished, I hope. So I'll figure out the things until next class, and I think I'll circulate new link via NPTEL to all of you. So this was lecture 1. In lecture 2, the CAD was studied. CAD means computer aided design. In CAD, where we make 3D models, we save the CAD in STL file format. For example, when we write something in Word document, we save it in PDF format, because sometimes when we print a Word document, some tables and figures get displaced, and you will see some interruption in the figure names, and maybe the table is in one page and the table name has gone to the next page. There is some problem in the Word printing. But what I have observed is when I when I save my Word document in PDF format, the printing is easy. But in 2D printer, Word document can also be printed. But in 3D printing, only STL file format can get printed. So anyway, whatever you are making by writing some code or by just making a geometry in a CAD software, for example, SolidWorks, Fusion 360, CATIA, AutoCAD, etc., etc., you have to save it in STL file format. In STL, what happens is the whole geometry, if the geometry is like this, a distorted shape, the whole geometry will get saved in small triangles like this. Okay, the whole geometry will get saved in this format, in like spreading a numerous numbers of small triangles, white triangles, just to cover the full surface. You imagine you are covering a full surface of a particular object, for example this bottle, using small triangles. And why you have taken triangles, not rectangles, not prisms? Because triangle is a surface which can be made using minimum number of points. So, because in STL file format, if you are saving the CAT file in STL file format, so there will be points respective to the triangles. Now, triangles are made of three vertices. So, the points or the coordinates of each vertices of a triangle will get saved in a STL file. And if you have to make this object, this curves properly using small triangles, so you have to include numerous millions triangles. You have to fill this bottle with millions of triangles just to cover it, because that is what done in STL. So that's why triangle is chosen, so that at least to have that unit surface, which is triangle, will have minimum number of vertices, which is 3. And the vertices of these triangles, like those 3 vertices points or points, 3 coordinates, again one coordinate will include x, y, z direction. So there will be lot of data, you can imagine. Again, these triangles will be vector, not scalar, obviously, because you are making one geometry which is in 3 dimension. So to make it vector, the triangles will have a direction. How a triangle can have a direction? So normally we make a normal to the triangle showing a particular direction, which direction will be only outside the material or outside the geometry. So if this bottle, I'm drawing this bottle here, so I have this bottle and I want to make the CAD model of this bottle as STL. So if there is one triangle here, the normal vector of this triangle will be outside the bottle, because one triangle have can have a normal in this direction or in this direction. But with the right hand thumb rule, we will name it like this, and for this the normal will be outside the bottle or the object. So I don't know how much clear I am. So that's why, because this time span is very little, so that's why I would suggest you first watch the videos. If you are not clear about some point, you can ask me here, because you can't ask sir there. So in CAD explanation, or how CAD works, how STL works, there are different strategies which are responsible to make this type of objects by STL formation. Before that, what is the full form of STL? Can anybody tell me? Okay, we have some questions. Yes, STL. Stereolithography. Okay, so the STL term came from the stereolithography technique, which is now known as SLA under VAT photopolymerization. But that at that time there was only one 3D printing technique, which was stereolithography. So that's why it was called as STL. But later on, when all the techniques came, it was known that STL is the file format in which you have to save the file so that you can print it in a 3D printer. So the STL full form is standard, I'll not write it down, standard tessellation language. Someone has written it in chat box. It is also known as standard triangulation language because you are dividing the whole surface or the whole object in small triangular shapes or triangles. So that's why it's called standard triangulation language or tessellation language. And there is one question. One first question is, in VAT photopolymerization, the z axis moves from top to bottom or bottom to top? The answer is both. Depends. In one process, you'll find out, which is called DLP. There, the light comes from bottom. But in SLA, which is stereolithography, there the laser comes from top. When the laser comes from top, the build plate will be submerged inside the vat. The laser will come, cure the first layer, and when one layer is cured, this substrate will go deeper by one layer thickness, maybe here, and this is one layer thickness. And here, as the vat is full of resin, so now again over the cured part there is liquid resin. The laser will again cure the next layer. When it is done, the substrate will get dipped by again one layer thickness. Now two layers are cured over this substrate and one layer of liquid resin. This is how the process where the substrate goes from top to bottom. Now for the vice versa or opposite thing, again the vat will be filled with resin and the substrate will come from top. It is connected to a lead screw, okay, and it is connected to a motor. This substrate is dipped in such a manner that here only one layer thickness is denoted as T. So one layer thickness resin is present. The UV light will come from the bottom, or the laser will come from the bottom and it will cure the resin present over there. When one layer is made, this substrate will move up by one layer. Again, now here is one cured layer of resin and one layer of liquid resin. The UV or laser will again cure it, and this is how it will go from bottom to top. So both the configurations are possible. There is much more than what I have told here, like how it is being cured. There are LCD based SLAs, there are DLP techniques, there are pixel based DLPs. So I'm not going into that. This is how the overall process goes. I think you have got your answer. The next question is this triangulation made over the external surface only? No, all over the object. If the object is solid, in a whole solid density, the triangles will be made. And there is slicing. So maybe you can think of the surface where the triangulation will be made, and it will just means the triangulation has no purpose in the solid body. The triangulation has purpose in the surface only, because in the solid body the triangulation is not needed. The In the solid body there will be layers, and in layers the triangulation will not be helpful because there is something called hatch strategy. So if we have a cube, for example, if this cube is getting printed, so I am drawing the top view here. Maybe I'll go to the next page. So this is the top view of the cube. Okay, one second, I'll answer your question. So from the top view, the UV or laser can just, or in FDM the material can get deposited like this. Okay, one way. The next way is it can get deposited like this. One way is it can get deposited like this. After this it will fill this path like this. So there are multiple things. These are called scan strategies. So I would say that the tessellation is not made inside. That tessellation is important for the surface only, because inside there will be layers, and each layer there will be hatch strategies. I think you have got your answer. So I would say no. In the body, the tessellation is not there. Support generation compulsory in VAT photopolymerization. So if you have a part like this, which is attached to the substrate like this, in every additive manufacturing process, you will need the support structure under this overhang portion. There is no additive manufacturing process where you will not need any support structure if your part is like this and your part has an overhang portion like this. Okay, so there are other things also. If you can just make this part like this, then you'll not need any support. No support is needed. But if you have to make a part like this part is not a good example. But for example, there is one part where there is a need of support because there is a overhang portion and which you cannot avoid anyway, then your support structure is needed there. I think I'm clear. Okay, so now as we don't have much time left, I'll go for one thing. That is, in week 0, you had some assignments which you were supposed to complete or right attempt. So I have those questions from previous year, and I have seen that actually I have taken another NPTEL course also previously in previous year, where previous year questions were used to be different from this year question. So I used to discuss the previous year question in one class so that people can attempt this year question easily, so that they can get an essence. But here in this course the previous year and this year questions are similar, so I cannot discuss. So what I will discuss at the end of each classes is I'll discuss the one class before quiz questions that you have already attempted, so that if you have any doubt about the questions, we can clear the doubt. So I'll need help of you guys for this. I don't know the answer of these questions, maybe. So you have to tell me the answers. What LOM stands for? Laminated object
Laminated object
manufacturing.
manufacturing.
Next question is, which type of CAD file is mostly used in 3D printing machine? I have
STL.
noted this word a lot. Next is SLA stands for. You know the answer.
Stereolithography.
Hmm. Then, which is the use of doctor blade in 3D printing process?
Layering the part.
Okay, so this question you may be right because I don't know the answer of this question. I was unknown to this doctor blade. Maybe layering the part.
Actually, blade is used in recorder blade.
Doctor blade is something else. Recorder blade is something else. So maybe doctor blade is another name of recorder blade that I don't know. It may happen. Then your answer is right. Otherwise, I don't know. I'll find out this if doctor blade is also known as recorder blade. Next is STL.
Both B and C.
Standard tessellation language and stereolithography. Other than this, also we can call it as standard triangulation language. The tool and fixtures used in additive manufacturing processes are the something object geometry.
Independent too.
Hmm. Next is the support is required to realize
overhang and pre-processing.
Overhanging and
to
post processing.
realize the overhang
Pre,
features of the object. Identification of the region required support is carried out at the pre-processing stage. Last question.
Overhanging and post processing.
pre-processing.
Pre-processing. Because support generation is something that you have to do in the part generation in CAD or the object placing in the software before printing. So there is one step before printing where you have to place the object, slice it. Slicing means defining the layer thickness. Then you generate the support there. So otherwise, if you have printed the part and the support is not required, so it's fine, support is not required. But if the support is required, then your part will not get printed. So the analysis is done before printing. Okay. Last question is, a digital image is composed of pixels, and these pixels are
Triangular,
in STL file.
triangular,
Yes.
triangular,
Yeah,
triangular.
triangular. So these are the questions that I had. So if you have any doubt in between, you can mail me in this email IDs. You can note out the email IDs. You can just mail me, because in previous classes there were students who used to mail me their doubts previous to the class. Because this time additive manufacturing is something that I am used to it. Maybe I don't know everything about additive, obviously, but I am a beginner in additive, so I'm also learning. So I know a little bit that I can share, which knowledge I can share with all of you and can teach you nicely. But in previous year, I have taken one course which was far away from my domain, which was a material engineering course, and I am from mechanical background. So my background is I am a mechanical BTech, and then I have joined direct PhD after that. So that course was way too far from my domain. So people used to tell me their doubt via mail so that I can clear their doubts in the next class. Just do a little bit more research. So you can also mail me. There is no problem. If you have any other doubt, you can ask me, or any specific topic from week one, lecture two to be discussed right now. I have 10 minutes left. Okay, can you tell me what is CSG from lecture 2?
Slit tips solid geometry.
And what does it do? How does it work?
Basically, it does some Boolean operation of standard geometry.
Yes. Okay, and what about the boundary representation?
which is having only surfaces, uh, and then it is connected to join a solid.
Mm. Then feature based modeling?
It's like extruding a surface or revolving a line like that to get a solid.
Yeah. So these features are mainly there in CAD softwares where you do perform these operations of revolve, sweep, extrude, cut. Then there are formats by which you can represent the STL. So what were those formats?
Boundary representation.
That is fine. How you can represent the STL file to the computer?
Okay, binary and that another
ASCII format.
ASCII
ASCII.
format. Yeah. So did you understand the ASCII and binary one?
It's quite tough, I think. Actually, eh, he gave
It's
some
nothing
demo
like you
also, but
just. Yeah, please,
yeah,
can you repeat?
yeah, he gave some demo using system and explained a few things, but we can understood some basics alone, not that much deep.
Yeah. So it's like if you're working in additive, you should have a generalized idea about these things, ASCII and binary form, so that if people are asking what is STL, how can you represent an STL in your, how can you feed the data to computer without making a model, these ASCII binary things are useful. Otherwise, for normal 3D printing, we make the model in CAD, we save it in STL, and we feed it to the printer, and the printing is done. But otherwise, it is very important to know how the STL is really working in the background. But you do not have to write any code or something like binary or ASCII for printing. So no need to be worried about it.
Yeah,
But
but
it's good
as a
that this.
normal, something's very tough actually. We will get a question right in the exam, right?
I think yes, yes, ASCII and binary, but not that hard. Okay, what is the difference between geometry and topology?
So optimized geometry may be topology.
No, topology is means how it is arranged or oriented the geometry. It is
Yeah, both the answers are correct. For topology, like for example, for lattices, the optimized geometry is the topology. And your answer is also correct. Topology is how the object is looking like for example, this bottle. And geometry is what are the dimensions of the bottle, that I can write down and make the bottle and draw the geometry of the bottle. But based upon the dimensions, the topology may look different from the geometry. And if somebody gives you points, like there are triangles, like there are 3 points, coordinate of 3 points, and you have to tell me whether the triangle is possible or not. So what will you do?
We have to get determinant, and it is zero means it is not a triangle. Calling.
So these things are very easy, and this can come in exam. Or like if there is one triangle with different coordinates, what will be the normal to the triangle, how it will be oriented. And if there is a circle or circular object, and there are some tolerances, what will be the number of triangles for angle tolerance, or what will be the number of triangles so that the chord height will be minimal. Like here, this is the chord height, and here this will be the angle tolerance. So there are formulas, very basic formulas, so you can see, I think. Yeah. Okay. So this call will also end very soon, unfortunately. So also our time is done. We can stop the meeting here if you don't have any more doubts.
Thank you, ma'am.